In this video, we will continue writing and graphing equations of hyperbolas. So let's start with a squared. A squared is always going to be that first denominator. So if a squared is 16, then that means a must be 4. Actually, we should say what the center is right away. The center is going to be the opposite of this and the opposite of this. So the center is going to be 3, 2. Let's graph that. So the center is here at 3, 2. So notice how this 16 is the denominator of the x term. That means I will do my plus and minus 4 in the x direction. So starting at the center, I will go right 4 and left 4. These are my vertices. So I have a vertex at -1, 2. And I have another vertex at 7, 2. Okay, let's find the b value so we can get the co-vertices. The second denominator is always going to be b squared. So b is going to be 3. Notice that the 9 is the denominator of the y term. So I will do plus and minus 3 in the y direction. So starting at the center, if I go up 3 and down 3, these are my co-vertices. So 3, -1. And 3, 5. Now that I've got my vertices and my co-vertices, I can draw this rectangle that I'm going to need to find the asymptotes. So just draw a rectangle as a dotted line that goes through the vertices and the co-vertices. Alright, so the diagonals of this rectangle will contain the asymptotes. So the asymptotes pass right through the diagonal. So I'm going to have one asymptote that goes like this. And I will have another asymptote that goes like this. We could go ahead and graph the branches now of the hyperbola. These red dots are the vertices, remember. So the branches should start from the vertices and approach the asymptotes like this. Okay, so now we've graphed the hyperbola. Let's go ahead and find the c value so we can graph the foci, which should be in the interior of each branch. Okay, so for hyperbolas, we know that the relationship between a, b, and c goes c squared equals a squared plus b squared. For ellipses, it's minus, but for hyperbolas, it is plus. So c squared is equal to 16 plus 9. So c squared is equal to 25. So c is equal to 5. So I can use that 5 to see where the foci will be. I will go 5 to the left and right of the center. So I will have a focus here, and I will have a focus here. The leftmost focus is the point -2, 2. The rightmost focus is the point 8, 2. Alright, while we're dealing with all these letters, let's go ahead and do letter E. Eccentricity is always c over a. So that's going to be 5 over 4. Last but not least, the equation of the asymptotes. We're basically going to use the point-slope form of a linear equation. But we're going to specifically pick the center of the hyperbola for our point. So you can always use the following model then. Y minus k is equal to plus or minus m times x minus h. Okay, again, the h and k, that's the center of the hyperbola. So we know that the center is 3, 2. So the 2, the y-coordinate, is going to end up here where the k goes. So I'm basically doing the opposite of this. So I'll have y minus 2 equals. And then I've got plus or minus m. M is the slope. So just pick either one of the asymptotes and analyze the slope. I recommend starting from the center. And then what's the rise and the run? From this point to this point, it's up 3 and over 4. So that's the slope. Okay, and then we have x minus h, which really means just do the opposite of the x coordinate. So x minus 3. So that's it. This equation actually captures both asymptotes because of the plus or minus. The plus 3/4, that's the slope of the positive asymptote, the upward leaning asymptote. The negative 3/4 is the downward sloping asymptote. So that's it for number 5. Looking at number 6, let's start by deciding what the center is going to be. It will be the opposite of these two numbers, but be careful of the order. So the x-coordinate of the center has to come from the x part of the equation. So the minus 2 will go here. The y-coordinate of the center will come from the y term of the equation. So the positive 4 will go here. So the center is negative 2, 4. Let's go ahead and graph that. So here's the center, negative 2, 4. Now let's find the a value and use that to get the vertices. So we know that the first denominator, the positive denominator, is always a squared. So that means that a is 2. Notice that the 4 is the denominator of the y term. So I will do my plus and minus 2 in the y direction. So starting at the center, if I go up 2 and down 2, these are my vertices. So that is negative 2, 2, and negative 2, 6. Alright, let's find the b value and the co-vertices. So we know that b squared is the second denominator. So that means b is going to be 5. Notice that the 25 is the denominator of the x term. So I will do my plus and minus 5 in the x direction. So I will go 5 to the right and 5 to the left. These are my co-vertices. So that's going to be negative 7, 4, and 3, 4. Now that we have the vertices and the co-vertices, let's go ahead and draw that rectangle that passes through the vertices and the co-vertices. Draw the rectangle as a dotted line. And know that the asymptotes will pass through the diagonals of this rectangle. So this is up 2 over 5. So I'm going to have an asymptote that goes like this. And I'm going to have a downward sloping asymptote that goes like this. So now I could go ahead and draw the branches of my hyperbola. Remember that these red dots are the vertices, so the branches will be here, and of course they will approach the asymptotes like this. Okay, so this is what your hyperbola should look like. We're going to need the c value to locate the foci, which should be in the interior of each branch. So for the c value, of course, remember that c squared is equal to a squared plus b squared for hyperbolas. So that means c squared is equal to 4 plus 25. So c squared is equal to 29. So c is equal to the square root of 29. For graphing purposes, it would be useful to know the decimal approximation. That is approximately 5.4. Okay, so starting at the center, if I go up 5.4, so here's 2, 4, 5, 5.4 would be about here. There's a focus. Okay, 2, 4, 5.4 down would be about here. Now, when I label these, I cannot use 5.4. I'm going to have to use the radical 29. The x-coordinate is easy. The x-coordinate of this focus, for example, is definitely right at -2. So I know it's going to be -2 comma something. The y value takes a tiny bit more thought because of the radical 29. Start at the center. Notice that the y-coordinate is 4. So you can think of the y value of this focus as being 4 plus something, because we're starting at 4 and we're going up. We're going up by radical 29. Okay, so the upper focus has the coordinates -2 comma 4 plus radical 29. Similarly, the lower focus is going to be -2 comma 4 minus radical 29. Okay, the eccentricity is always the c value divided by the a value. So that's going to be radical 29 over 2. So that just leaves the asymptotes. Remember that you can use the following model to get the asymptotes all the time. Y minus k is equal to plus or minus m times x minus h. This is really just point-slope form of a line. But the point that we're using is always going to be the center of the hyperbola, h comma k. So keep your eye on the center. Okay, remember that our -2 comma 4. So basically we're going to do the opposite of these two values and put them here and here for h and k. But be careful, this is the y coordinate. It's going to go in the y part of the equation. So y minus 4. This is the x coordinate. It's going to give us the x part of the equation. So the opposite of this will give us x plus 2. Now we just need to put the slope in. So let's look and find the rise and run. Just look at this portion of the asymptote. Do you see how it goes up 2 and over 5? Rise over run. So the slope is 2/5. So we're just going to put plus or minus 2/5. The plus or minus is so that we can have one equation that represents both asymptotes, the upward sloping asymptote and the downward sloping asymptote. So that's going to do it for number 6. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.